Welcome to the Paynetech bite-size reviews of the Arduino Due. This is the first ARM chip Arduino that they released. It has a SAM3X8E ARM chip on it, which is extremely powerful with very powerful processing instructions that do lots of things in one hit. It also runs considerably faster than any other Arduino, which the rest of them all at around 16 megahertz to date. This runs at 84 megahertz, so that gives you some idea of the power that's available, but there are some concessions to be made there. The operating voltage is 3.3 volts, and that's on all pins as well. It's got two USB ports here. It will take power over the USB, and it will also take power from this little DC socket here. Between 7 to 12 volts is the recommended voltage. You can go 6 to 16 volts, but again, I would recommend that you stick within the recommended limits, which is 7 to 12 volts for maximum stability. It will automatically flip between the USB socket and this little DC socket for power, depending on where the power is available. Now, just like a Mega, it has 54 digital pins in and out, but they only run at 3.3 volts. So if you've got 5-volt logic, 5-volt breakout boards, that sort of thing, you're going to have to go through a level shifter in order to use those pins. Now, of those, 12 of those pins will do PWM out. They have built-in internal pull-up resistors that are turned on and off via software in your code. They are 100k resistance. Analog inputs, there are 12, and they are all dedicated. They are along here. So there's the 12 analog inputs right there. There are two analog outputs. There's actually a DAC on this device. Two 12-bit analog outputs, so you could potentially get stereo audio out from this board in 12-bit resolution, if not 16-bit. All 54 of these digital I/O pins are actually interrupt pins on this device, and it will sync 130 milliamps across all of the pins, so just bear that in mind. There's only so much that this board's going to be able to sync before it heats up, burns out, what have you. DC current for the 3.3 volt pin is 800 milliamps. For your information, but one of the massive benefits of this board is not just the speed, but also the amount of memory that's available. There is a 512 kilobytes of flash memory or sketch memory. That's a huge amount of memory compared to all the other devices, which are all around the 32k mark. Program memory is 96 kilobytes in total. It's in two banks, one bank of 64 and one of 32. There is no EEPROM. However, there is a little software library called Due Flash Memory, which you can use to emulate an EEPROM using the flash memory, of which there is plenty of it. The onboard USB chip is Atmel A000062. Both of these little ports here are micro B sockets, and both of them feature 500 milliamp overcurrent protection. You can do serial via the USB and UART TTL at 5 volts. There are 3 UARTs as well. I2C on pins 20, 21, SDA1 and SCL1, and SPI via this little SPI header right here. Length is 102 millimeters, width is 54 millimeters. I'll just turn that over so you can see the other side briefly. And weight is around the 36 gram mark, but it's also worth mentioning shield support is, as far as the shields available for the Arduino Uno and the Mega, minimal, because they're all expecting 5-volt logic. This runs on 3.3 volt logic, so if you're going to buy shields, triple check, or buy specific shields for the Due, but don't expect to buy an Uno shield or a Mega shield and just expect it to work out of the box, because it's unlikely to. So you're going to need to use your brain to use this board, but it is incredibly powerful. Please consider making your next purchase via paynetech.co.uk. See you next time.